This is an everyday situation in an oil refinery. You have an oil tank and you have 2,000 gallons per minute flowing in and 1,500 gallons per minute flowing out. And in oil refineries, they want to see how fast this tank will fill up. So if it overflows, they don't have a hazard because oil is very flammable. So today we will work out what the time would be for this to fill up. So first you have to find the volume of the cylinder. You have to find the volume and what it can withstand, how much capacity it can hold for it not to spill over. So this is a cylinder tank. So you use the volume of a cylinder. You use the formula for the volume of the cylinder, which is V equals pi times diameter squared over 4 times the height. So the height is 40 foot and the diameter is 20. So you have V equals pi times 20 squared over 4 times 40. Okay? When you do that math, that comes out to 12,560 feet cubed. So this is the capacity that this tank can hold. Now we want to find out how much time it would take for this to fill up. So we would use mass balances, which is the accumulation formula, which is accumulation equals in minus out. That is the same as the change in mass over the change in time equals the mass flow rate in and the mass flow rate out. You can substitute rho V for M because when you rewrite that equation M equals rho times V. So then we would have D rho V over dt equals rho V in minus rho V out, which V in is equal to V1 and V out is equal to V2. Okay. Next, your rho would come out because the liquid is assumed to be condensified. So rho dV over dt equals rho V, which is V1, which is Vn, minus rho V2, which is V2, which is that. So rho would cancel. Now you have dV dt equals V1 minus V2. Okay, now dt, when you're solving for dV, you would move dt over here. So then you have dV equals V1 minus V2 dt. dV equals V1 minus V2 times dt. dV is the change in volume of the oil tank. So we take the integral of both sides, which would be Vmax to 0 of dV. Then we assume that V1 minus V2 is a constant because you have V1 minus V2. So you can pull that out of the integral equation. So you would have the integral from t to 0 of dt. And then t is what we're trying to solve, and 0 because initial time is 0. And so then we have, when you take the integral of this, you have Vmax minus V to the 0 equals V1 minus V2 t minus 0. Okay, so Vmax equals V1 minus V2 times t. When you simplify all that down, this is what you get. Vmax is the number that we found earlier. And so when you solve for t, t equals Vmax over V1 minus V2. And this number will give you how long it would take for this oil tank to fill up due to this flow rate in and this flow rate out. Okay, so now we have T equals Vmax over V1 minus V2. Vmax equals 12,560 feet cubed. V1 equals 2,000 gallons per minute. And V2 equals 1,500 gallons per minute. So using dimensional analysis, so we can keep our units consistent, we take 12,560 feet cubed, which is our Vmax, and we divide it by 500 gallons, which is per minute, so we have 1 minute. And we use the conversion to feet cubed in gallons. So 1 feet cubed equals 7.48 gallons. So you get a calculator and do this math. 12,560 divided by 500 times 7.48, and that equals T equals 188 minutes. Okay, so this T equals the amount of time that it takes this tank with this flow rate in and this flow rate out to fill up. By simple integration, using this to find the flow rate in and how fast it will take to fill up, you can avoid this overflowing, avoid oil being on the ground and becoming hazardous. So by simple integration, we saved maybe someone's life. We saved how a plant could become hazardous. Integration is used every day in oil refineries, and that is what I want to do by pursuing my degree in mechanical engineering.